this video, we are going to practice writing expressions. This is one of the most important skills for future elementary teachers because students need to connect words, pictures, actions, and symbols. Let's start with the story. Erin bought 15 bags of potato chips. She shared 6 with her friends. She then put the remaining bags of potato chips equally into 3 small boxes. How many potato chips were placed in each box? Let's think through the story. She starts with 15 bags, and she shares 6 bags with her friends. That means she has 15 minus 6 bags left. She then puts the remaining bags equally into 3 boxes. So we divide the remaining amount by 3. So our expression is 15 divided by minus 6 in parentheses divided by 3. The parentheses matter here. They show that we first find out how many bags remain, and then we divide by 3. Without the parentheses, the expression would not clearly match the story. Now, let's think about expressions from visual designs. We see this set of dots. And we want to write an expression for the total number of dots. One way is we could write each row. So the first row has 1, the second row has 3, followed by 5, 7, 9, and 11, and then we start going back down. 9 plus 7 plus 5 plus 3 plus 1. That expression matches the rows exactly. Another way we could do this is to notice symmetry. The design grows up to 11 and then shrinks back down. So we could say that there are 2 rows that are both 1, 3, 5, 7, and 9, plus 1 extra row that's 11. We have 2 copies of the smaller odd number rows, plus the middle row of 11. Both expressions represent the same total number of dots. They look different, but they describe the design in different ways. And these are not the only way to do it. This is helpful for students because it shows that expressions can reveal how someone sees a picture. Now, let's look at this design made of stars. One expression that we could do is I could think about breaking this into a box here. That one would be 3 by 5. I could then consider this middle piece right here. That is a box that is 4 by 8. So we would need to add 4 times 8. And then I can consider this last piece down here. That would be 3 times 5. This expression describes the design in 3 sections. 3 rows of 5, 4 rows of 8, 3 more rows of 5. We could also combine the 2 groups of 3 rows. So we could say that there are 2 groups that are each 3 by 5, plus an additional group that's 4 times 8. This is another expression for the same total number of stars. Now, let's interpret some expressions. Let's consider 10 times 8 minus 2 times 3 squared. In this case, we could think of the entire rectangle of squares being 8 across and 10 down. So that would be like if this entire space was filled with my stars. But it's not. We have these 2 spaces that are missing, and they are each 3 by 3. So we would need to remove 2 sections that are 3 by 3. So the expression means we start with 80, and then we need to remove 18 for those missing pieces. Next, let's consider 2 times 7 times 5 minus 4 times 2. So this one we'll consider 2 rectangles that are each 7 by 5. So one of them will be right here. And then the second one is here. However, in this case, we have double counted a big group of stars right here in the middle. These here. That is a 4 by 2 rectangle that we now need to remove so that we only count it once. The structure tells a story. 2 large groups minus these smaller groups. These examples show that writing expressions is not just about memorizing rules. It's about representing meaning. When students write expressions from stories or pictures, they are learning how symbols can describe actions, quantities, and structure. That is a powerful teaching idea.